In this video, we're going to look at problem solving with similar 2D shapes. In the video, our main focus will be similar triangles. Let's start off by looking at the idea of similar shapes. In maths, two shapes are said to be similar if they are identical shapes but different sizes. So, with similar shapes, one will be an enlargement of the other. Their side lengths must remain in proportion. If we start off by looking at some rectangles, I've got rectangle 1, rectangle 2 and rectangle 3. With rectangle 1, I'm going to write that this side length is going to be 1 centimetre and this side length is going to be 2 centimetres. With rectangle 2, let's say this side length is 2 centimetres and this one is x centimetres. If rectangle 1 and rectangle 2 are similar, we can go ahead and find the value of x. So let's say these are similar. What we can see now is that going from rectangle 1 to rectangle 2, we've simply multiplied each side length by 2. Or, if you like, going from rectangle 2 to rectangle 1, we've divided each side length by 2. It's clear what the value of x is going to be. All we need to do is simply multiply the 2 by 2 and we could write now that x is equal to 4 because this rectangle is similar to the first one. All we've done is put a scale factor enlargement of 2 on it and kept its proportion. So if these weren't rectangles, for example they were triangles, with similar triangles all of the angles will remain the same size, one is just enlarged from the other. Now if we look at these particular corresponding sides, we can see now that this side length and this side length are corresponding. The 1 is matched with the 2. If we look at this side length, which is the 2, and this one, which was the 4, or x as we knew it, these two are corresponding too. If we now look at rectangle number 3, and we said that this was 0.5 centimetres, for this to be similar to either of these, what we would need to do is make this side length here 1, because we can see now that it's half the size of the first one in terms of this side length. Therefore, it would need to be half the size of this side length to remain in proportion. This has not remained in proportion. Therefore, these are not similar. We would need it to look something like so. So, whilst these are all rectangles, they are not the same shape. So let's extend this on to looking at triangles. What I'm going to do is draw an isosceles triangle. It certainly doesn't need to be isosceles for it to be similar. It's just easier to see with this particular thing I've got on the screen. So if I place the smaller triangle on top of the larger one, what we can see is that they share the same angle just here, and these two lengths are parallel. If I move this to one side, we can put on now that this angle is going to be the same as this one. This one right here, using a different notation, will be the same as this one here. And this one, if it was isosceles, would be the same here. If it wasn't isosceles, I'd just put a third line on here. This side length will be the same as this one if it's isosceles, and we will have now the corresponding sides that will remain in proportion. So let's say, for example, I said that this length right here was 9 centimetres, and I said, for example, now this side length was y centimetres. I said that this side length was going to be 3 centimetres, and this side length is 2 centimetres. Straight away, knowing that those two triangles are in proportion, we could clearly work out the value of y without really trying. We can see that the larger triangle is 3 times bigger than the smaller one, or the smaller one is a third of the size of the larger one. So quite clearly on here, y is going to be 3 times the size of this, which should give us 6. Let's say we didn't spot that scale factor. Let's say we needed to think, well, I can't see that. I can't see a direct scale factor enlargement. what we would do here is use algebra to set up a little equation. What we know is that we have corresponding sides. So y now and the 2 are corresponding. What we can also say here is that the 9, which is that one, and the 3 are corresponding. We could also say that this one and this one are also corresponding. We don't need that to set up the problem, or set up the equation to solve the problem. All I'm going to do is rely on proportionality. Here are two choices for you. What we can say is that the ratio of y over 9 must be the same as the ratio of 2 over 3 if these remain in proportion. That's obvious. Now, that's one choice. What I could do, if I just put a line here, is set up a different equation. What I can say is that the corresponding sides will have a ratio, y over 2 will be the same as 9 over 3. So their ratios are the same. As you can see from here, all I've done is set up two different equations for us to solve for y. So if we took this approach, all we would do is multiply both sides of this equation by 9. By multiplying both sides of the equation by 9, I clear the fraction. So y would be equal to 9 multiplied by 2/3. Remember, in maths, multiply is of. So all we're doing is looking at 2/3 of 9. You can, of course, use a calculator for that if you want, but we can just write 2/3 of 9 is 6. And we knew that anyway. With this one here, I've multiplied both sides of the equation by 2. So we get 2 multiplied by 9 over 3. Well, 9 over 3 is just going to give us now 3. So y would be equal to 6. And we can see that it gets us that answer anyway. So if you can't spot them, you just set up an equation and consider the corresponding side lengths being in proportion, or one just being a scale factor enlargement of the other. Let's say let's put on another triangle on top of this one, and let's say I put this just here, and I did this, and I said, right, we'll start at the same place. These two now, this one and the new one, are not similar triangles. They've not remained the same. The angle has changed, therefore the proportion now will alter. We don't have corresponding angles. These angles have changed. So do make sure it's an exact enlargement of the other, and you can tell that by matching up the angles on here. So if we had, for example, let's say we've got a right angle triangle like so, and I'll just put this on. Let's do another one and make this one a little smaller. Then these two are similar triangles. They share that angle to the bottom here, the bottom right. These two side lengths will be parallel to one another. We've got the right angle here, and this top angle will be the same. What we'll do in the video is look at solving when we have them like so. What we often have are triangles that look like this. We have them on top of each other, we have them inside each other, we have them flipped over. It's no problem. Once you can match up the sides, we're okay. So let's go ahead and look at solving some problems. So what we need to do is find here the value of p given that these are similar. We can see that this angle here is going to be the same as this one right here. This one here is the same as this one here. So by the laws of the angles in a triangle, this one here is going to, and we don't need to do that. This one here is going to be the same as this one here. So these are similar. Okay, straight off you probably spotted it. The larger one is going to be 3 times the size of the smaller one. We can see that. The corresponding sides here are the 6 and the 2. So if I looked at this one here and said, well, that one's 6, that one's 2, these are similar, which we can tell. So therefore, this one is 3 times smaller, or this one is 3 times bigger. So to find p, I just need to divide 8.4 by 3. And you're absolutely right. So if we wanted to find p, what we could say is, well, p is just going to be 8.4 divided by 3, because it's going to be a third of this size. We know that this side length here is now going to be corresponding with this one just here. So straightforward. What is 8.4 divided by 3? 2.8. So 2.8 centimetres. That looks pretty good. Okay, 6 and 2 are lovely numbers. Let's say they weren't. Here are my choices of setting up that equation. what I can do is look at the ratio of the sides. P over 2 must be the same as 8.4 over 6. Or, what we could have said is P over 8.4 must be the same as 2 over 6. So all I've done is said this one over this one must be the same as this one over this one, as their ratios remain. Or this one over this one must be the same as this one over this one. What I can't do, this is a big no-no, is say now that P over 8.4 must be the same as 6 over 2. Well, 6 over 2 is 3. This would give me 8.4 times by 3, which is what, 25.2? And quite clearly, P isn't 25.2. So you must make sure you are matching up the same sides with their ratios. So that clearly isn't the case. So on this one, again, I've done two different equations. I'm letting you choose. What we can say is P will be equal to 2 multiplied by 8.4 over 6. What you might see is 2 over 6 is a third. This is a third of 8.4, exactly what we got here. It's the same thing. Here, what we'd have is P is equal to 8.4 multiplied by 2 over 6. Well, 2 over 6 is a third. Exactly the same. We're going to get 2.8. We can't escape from that. You could even, if you were a bit crazy, do 8.4 over P will be equal to the same as 6 over 2. I wouldn't do this. I'd never put P in the denominator of a fraction because it makes the equation harder to solve. What you'd have is 8.4 over P is equal to 6 over 2, which is 3. That's not too bad because that gives us an integer, a whole number answer on the right. But if it didn't, it's going to be a bit messy. So 8.4 divided by 3 must be equal to P by simply swapping these over, dividing by 3, multiplying by P. But you can see it's a longer way round. So there we go, P's 2.8 regardless of how we do it. Okay, two similar triangles. We've got 3 and 5, we've got P, we've got 4 and Q, and we've got 5.3. We've got two unknowns. What we're going to do is look to solve. Straight off, you might say, I found the scale factor. Brilliant. Let's look at these corresponding sides. So the corresponding sides now here are the 3 and the 4. So what we can say is that the smaller one is 3/4 of the size of the larger one, or the larger one is 4/3 the size of the smaller one. What we need to be careful with here is that we don't set up an equation that has two unknowns. One equation with two unknowns we can't solve. In algebra, if you have two unknowns, you must have two equations. So what I don't want to do is set up an equation with P and Q. So what I'm going to do first is just put on these side lengths. I'm going to solve for one and then I'll solve for the other. So it's not that I need to solve for one in this particular case to solve for the other, but what I'm going to do is just go ahead and look at P first. So I'm going to say that P over 3 must be the same as the 5.3 over 4 as these remain in proportion. Now, P is going to be equal to 3 times by 5.3 over 4, which, if I wanted, I could write like that. So what you can see here is we've got 3/4 of 5.3, as we would expect, because P is just 3/4 of this side length. What's 3/4 of 5.3? 3.975. Let's just do it. So remember, in maths, of just means multiply 3/4, and we can write this fraction any way we want. Multiply by 5.3, 3.975, I guess. There we go, not too bad. So P is equal to 3.975 centimetres. Of course, what you could have done on this one is said, well, actually P over 5.3 will be the same now as the 3 over 4. And look what we're going to have, multiplying up 3/4 times by 5.3. You can write it like so, you can write it like so. I prefer, if you didn't just say, well, it's 3/4 of 5.3, I prefer these equations to be set up because the more challenging the problems are, the messier the numbers, the easier it is to get into this habit. Okay, now we're going to find Q. What I strongly suggest is that you don't use the value you've just found for P. If that's wrong, your answer for Q is going to be wrong. So all I'm going to do is take the information we're given in the question to solve for Q. So with Q, what I could say now is that Q is going to be 4/3 of 5 because 5 is 3/4 the size of Q. But instead, I'm simply going to set up one of two different equations. I could say Q over 4 must be the same as 5 over 3, which gives me Q is equal to 4 times by 5 over 3. 20 over 3 is 6.6 recurring, and that'll be 6.6 recurring centimetres. Of course, I could have done Q over 5 is equal now to 4 over 3, multiplying both sides by 5. Q is equal to 5 times by 4 over 3. Q is equal to 20 over 3, which is 6.6 recurring centimetres. What I don't really want to do is deal with bringing in P, this idea of P, put in 3.975. We could check that it works, don't get me wrong, but I wouldn't use an answer I found if they're giving me that information. So we found this to be 3.975. So if you wanted to, if you're in some kind of crazy mood, you could have said, well, actually, Q over 5.3 must be the same as 5 over the 3.975. So Q is going to be equal to 5 times by 5.3, we've just multiplied it, which is going to give me 26.5. 26.5 divided by 3.975. All I've done here is multiply these two. So if we look at that on a calculator, 26.5, hoping my maths is right, divided by the 3.975, well, 20 over 3, 6.6 recurrent. So we can see that we're right on that, and that backs it up. So it backs up both answers are correct, but as you can see, it's fraught with danger if your first answer is not correct. We weren't solving simultaneously either. We didn't need P to get Q. We didn't need Q to get P. Okay, two similar triangles. Difference here. The difference here is that one has been rotated as well as enlarged. Don't worry. If you can spot the corresponding sides, go straight at it. If you can't, simply redraw one of the triangles to match what you would like to see. So all I'm going to do is go ahead and redraw the smaller triangle. Please don't feel you must do this. Don't feel, oh, he's wasting our time. I can already see it. What I'm going to do is put the angle here where this one is, so I can just match up the corresponding sides. So that's there. I'm then going to put this one just here. So that one is just there. I know that the P is between the two angles, therefore the 4.1 is between these two angles. The 3.7 will go just here, and the corresponding side will be the 4.44. So that's 3.7. And then this one just here, the Q will go here. So we're back to where we were in the last question. I've simply turned that around so it's easier to see. Please don't feel you need to, but it's there if you want to. So let's solve for P, let's solve for Q. Remember, don't write, for example, P over 4.56 is the same as 4.1 over Q. You're not going to solve that. Two unknowns, one equation can't do it. So what I'm going to say is to solve for P, P over that is the same as this over this. So P over 4.44 will be the same now as the 4.1 over 3.7. So P is equal to multiplying both sides of the equation by the 4.44. 4.44 multiplied by the 4.1 divided by 3.7. I'm entitled, more than entitled, to write that. That's the same. So I'm putting the 4.44 in the numerator. It really doesn't matter. So let's go ahead and do that. So what have we got? 4.44 multiplied by the 4.1, and we'll divide that now by 3.7, and we're going to end up now with 4.92. So P is equal to 4.92. And as you can probably see, if we just look at that, does that kind of make sense? Well, if we look at it, well, it's certainly longer than this one. That one's longer than that one, so it's good to go almost. The reason I'm not just saying, well, I know the scale factor of this one, the scale factor isn't as obvious. You could find the scale factor by dividing this length by this one, but it's not as easy to spot, and that's why I'm hoping that you'd set up an equation. Right, let's look at Q. So what I'm not going to do is use my answer for P. So all I'm going to say is that Q over 3.7, we're given the 3.7, must be the same now as the 4.56. 4.56 over the 4.44. I could have gone Q over 4.56 is the same as 3.7 over 4.44. It does not matter. Hopefully by now you've got the confidence to choose either of these and just set them up and know that they're going to give the same answer. So on a calculator, what's that going to give? 3.8. Let's just check that. So 3.7 multiplied by 4.56 divided by 4.44, and let's get that value, 3.8. Nice. So Q is equal to 3.8, and remember these need to be centimetres because we're not given their P centimetres and Q centimetres. So just put the centimetres on. Often it'll be find the value of P when it's P centimetres, but if not, just put the units on. So there we go. If you've gone straight at it, perfectly fine. Okay, what we've got here are now, well, looks like one triangle with lots of dimensions. Straight off, I can see we've got this notation to say these are parallel sides. If we think about this as two triangles, they share this angle right here. These two are parallel, and they will now have this angle the same as this one. You just have to do angles in parallel lines. If you look at these ones, corresponding F angles, this one is the same as this one. This one is the same as this one. These are similar triangles. My preference here is to pull these two triangles apart. You certainly don't have to. But if you want a nice way of doing it, you take your pick on whether you like this or not. So this is the larger one and the smaller one. Straight off, you might see the scale factor. Look at these two corresponding parallel sides. These now are 6 and 4. The scale factor from now these two is 6 over 4. 6 over 4 is 3 over 2, which is 1.5. So the larger one is 1.5 times the size of the smaller one, or the smaller one is 2/3 the size of the larger one. You simply flip the fraction over. So if we got 6 over 4, simplifying this, we can have 3 over 2. So to go from the smaller one to the larger one, we'd multiply by 3 over 2. To go from the larger one to the smaller one, we'd divide by 3 over 2. Or we could flip this over and look at the reciprocal, which is 2/3. So you could multiply the larger one by 2/3 to get the smaller one. It's entirely up to you. So let's just go ahead and put this on. This is A, this is D, and this is C. This is A, this is E, this is going to be B. We've got these parallel sides, don't really need to put parallel sides on, and we know that this one is 6, this one is 4. We're told now that A to B is 4.9 centimetres. That is going to go there. We've got A to C, which is going to be P. We've got A to D, which is 5.5. We've got A to E, which is going to be Q. So remember, this angle is the same. This angle right here is going to be the same as this one. They are now on there. And then this one will be the same as this one. So let's look. We've got all the information in the world. That's all we need. Do you need to do that? No, you don't. You can go straight at what you see on here, and I'm not going to hold you back yet again. So let's solve for P. Well, P over 6 must be the same as 4.9 over 4. So let's do that. So P over 6 must be the same now as the 4.9 over 4. So P is equal to 6 multiplied by 4.9 over 4. I'm just going to put the over 4 here. And if you look at that, 6 over 4 is 1.5. 6 divided by 4 is 1.5. You're just doing 1.5 times 4.9, which we already knew. What's that going to give me? 7.35? Let's just, so 1.5. So 1.5 times by 4.9, 7.35. So P is equal to 7.35 centimetres. So that gives us that one. With Q, all I'm going to do is say now that Q over 4 is going to be equal to 5.5 over 6. I'm simply going ahead and saying now that this one and this one are corresponding sides, and then the top one just here and this one just here are corresponding. So this one over this one will be in the same ratio as this one over this one. You could have said, of course, this one over this one is the same as this one over this one. Whatever you do, don't swap them over midway through. So don't say q over 5.5 is the same as 6 over 4. It isn't. You'll get a crazy number, and that's not what we want. So q is equal to 4 multiplied by 5.5 divided by 6. Or, if you like, q is equal to 4 over 6 times by 5.5. Or it's just 2/3. Multiplies of, it's 2/3 of the 5.5. So in a calculator, just do 2 divided by 3 if you want, or you can put a fraction, multiply it by the 5.5, and that will give us now 11 over 3, or 3.6 recurring. So q is equal to 3.6 recurring, and we can just put that in. Q is equal to 3.6 recurring. Job done. And we do need to put centimetres. There we go, because again, these aren't Q centimetres or P centimetres. Okay, this one. So we got, again, one triangle with a line in it. I see this as two similar triangles, one on top of the other, and I like to split it up. You don't have to split it up, but looking at this one, I certainly would. So what I'll do, I'll draw two triangles. Go ahead if you're already happy to move ahead by yourself. Don't let me hold you back. But what I'll do is, these are the two triangles. Doesn't have to be immaculate. We know they share this top angle. We know that these are parallel sides here, and this one is there. Straight away, you might have picked up the scale factor. We've got now here 7 to 10. This one is 7, this one is 10. Let's now look at the information we're given. We're told now, remember, this is the smaller one, this is A, B, E. This is the larger one, which is A, C, D. We're told now on the diagram that 8 is 5.5. We're told on here that B to C, so let's put this on, B to C is going to be on here, this length right here, which I'm not even going to use because we're only finding the value of P. Not even going to use that one. All I'm going to do is put now this one here, this P. So the 2.5, do I need that? Well, I could put it here. It's not going to help me though. This one right here, D to E, is P. Right, here is a common error. If students split it up like this, they put A to D is equal to P. It isn't. It's P plus the 5.5. So what we have is P plus the 5.5. Because remember, all of this length right here includes this 5.5 here. So what we need to do is just find the value of P. This is straightforward. All we have is P plus the 5.5 divided by 10 will be equal to the 5.5 over 7. That one over that one will be equal to this one over this one. So let's go ahead and do this. Multiplying both sides by 10, P plus the 5.5 will be equal to 10 times 5.5, which is 55 over 7. So P, let's put this on, P is going to be equal to 55 over 7 minus the 5.5. And we can go ahead and find that answer. It's just straight in a calculator. So initially we were solving for P plus the 5.5, but as you can see, we can just go ahead and do that. So if we look at that on a calculator, we got 55 over 7, so we could do it as 55 over 7, and we would subtract from that now the 5.5, and what's that going to give us? 33 over 14. 33 over 14 is what we call an exact fraction. We could press our SD button to get a decimal approximation or truncate it, so cut it off by rounding to 2.36. Again, we don't. As I say, I prefer to leave it as 33 over 14, purely based on the fact that it makes any further calculations easier to do. So there we go, and that would be, on this one, metres. We're dealing with metres. I think while we're here, I'm going to introduce another letter and see if we can solve for Q. What I'm going to write here now is that AB is equal to Q. So let's put AB is equal to Q. So what I want to do is solve for Q. So let's put on here that this is Q. What we know is that A to C will be equal to Q plus 2.5. What I'm going to do now is solve for q. What we'd have is the following. We'd have q plus the 2.5 over 10. This one over this one must be the same now as this one over this one. So what we're doing is solving a linear equation for q where we've got now the unknowns in both denominators. At this stage, I'm going to cross multiply, or if you like, multiply both sides of that equation by 10 and both sides by 7. Or if you like, multiply both sides of the equation by 70. 70 is the lowest common multiple of 7 and 10. What I'll end up with is 7 multiplied by q plus 2.5 will be equal to 10q. So, just think about that. If you multiply both sides of this by 70, then that is going to give us 7 times by this, and that's going to give us 10 by that. Alternatively, cross-multiplying, you can look at it however you want to look at it. So, what we're going to have here is 7q plus, that's going to give me 17.5. So, 17.5. 7 times by 2 is 14. 7 times by a half is 3.5. So that should give us that, and that is equal to 10q. Subtracting 7q from both sides, 17.5 is equal to 3q, and then that is going to give us 17.5 divided by 3 is equal to q. So a bit more of a challenge. What we didn't need to do though is find the value of p before we could find the value of q, which might be the case in some scenarios. Let me just, my mind is kind of wandering after half an hour or so of doing this. So yeah, that's 70, and then if we divide that by 3, 35 over 6, 5.83 recurring. So q is going to be equal to 5.83 recurring, and we're in meters in this one, aren't we? So as you can see, not a problem. It's just setting up another equation and looking at proportionality, or the two side lengths that are in proportion. Right, here goes. Here we have similar triangles, but they look like egg timers. All that's happened now is the exact same scenario that we had. Let's go to this one, but this has been spun round. This part has been spun round. So if we look, this part would be spun round. What we've got, and let's see if I can locate it again. I don't know where it went. In fact, is that? Oh no, we're doing another one. Okay, let's do this one first. It seems I jumped one. Doesn't matter. Right, let's deal with this. Again, do you want to split it up? You can do. If you don't do it. I prefer to split it up into smaller one and larger one, purely based on the fact that I can see the corresponding sides a lot easier. So this is what we'll have. Smaller triangle, larger triangle. Two parallel sides. The angle here is shared. That's fine. The angle here is shared. These are the same. So A, this is the little one, this is ABE. So ABE. This is the larger one, ACD. So let's put on the side lengths. A to B is 5, that's there. B to C, where's B to C? So B to C, right, B to C is 4. So if this is 5, and if we put it on here, if this is 5 and this is 4, then A to C is going to be 9. So the advantage of not splitting it up is that you could probably see what that's at, but I still like to do that. E to B is 3.5. That's just there. That's 3.5. C to D, or D to C, is P. A to E is going to be now on here 3.8. And then we've got on here, so A to E is 3.8. And DE, which is this bit, is Q. So A to D is going to be Q plus the 3.8. So, can we go ahead and solve this? So let's see if we can. Right, we've got some issues here because on this one we've got two unknowns. So what I need to do first is solve for one, and then on it, in fact, no, we can do this, can't we? Shouldn't be an issue at all. So I don't need any help with this, in fact. So if we look at it, here we can do Q with these ones. That one over that one is that one over that one. With P, we can do this one over that one is that one over that one. So again, no issues with this. Let's do P first. P over 9 is equal to 3.5 over 5. So P is going to be equal to 9 times by 3.5 over 5. And let's just whack that for the calculator. So 9 times by 3.5, and then we will divide that by 5, and that's going to give us 6.3. So P is equal to 6.3. Now we need to do Q, so we can say that Q plus the 3.8 over 9 will be equal to the 3.8 over 5. Just taking this one over this one has got to be this one over this one. I was kind of hoping that this would be a bit more challenging. So that's going to give me that over that. And then I just need to subtract the 3.8. So let's do 9 times by the 3.8. Divide that by 5. So what's that give me? 6.84. So Q plus the 3.8 is equal to 6.84. Let's just check that. 6.84. So all we do is subtract the 3.8, which should give us 3.04. Let's have a look at that. So Q is equal to this, subtract this, 3.04. And we're dealing with, on here again, we'd need to put the units. So that's millimetres and that's millimetres. So nothing crazy with this one. It really isn't an issue. Okay, this is where we were. For some reason we jumped past the last one. This is no issue. All we've got, this has been, I see this, you don't have to, this has been pivoted about this point or rotated about the top. So what we've actually got here, if I turn this back round, what we'd have is the P corresponding to the 4.25 and the 3 corresponding to the 5. So if you already want a ratio, there's your ratio, or scale factor enlargement is 3 to 5. But what I would do here, and please, I kind of try and make these videos for everybody, but don't want to hold people back if you're thinking, oh, I just can't be bothered to split this up. So what we've got is this angle right here, and we've got our parallel sides. So if I put my angle just here, on the larger one, this is 5, this is 4.25. What we have here is the 3, and the P is going to be just here. So that's nice and straightforward. Because, as I say, if I just rotated that shape about here, what we'd end up with is exactly what we've just been dealing with. We'd have this line across here, this angle would be just here, same as this one, and the P would be on top here. So with this one, really straightforward, and we can simply say on here that P over 3 would be equal to 4.25 over the 5. So P is going to be equal to 3 times 4.25 over the 5. Or if you like, it's going to be on here 6/10 or 3/5 or 60% of 4.25. So you can just type it into a calculator, 3 times by the 4.25 divided by 5, or any other variation, entirely up to you. That gives 2.55. So P is going to be equal to 2.55 in centimetres. So again, we're not given its P centimetres, so we just have to add that on. Could have gone anyway with that. P over 4.25 is the same as 3 over 5. Would have got this same thing. Okay, right, this one. What we've got again is just a simple rotation about a point. So if we look at the angles now, what we can see, this one here will be, and I'll put double on that one, don't need to, it's going to be the same as that one there. If you think Z angles, alternate angles, in when you've done your angles, this one right here is an alternate or Z angle with this one. So if you wanted, you could draw two separate triangles if you didn't want to go ahead and go straight at it. So if we have the larger triangle and we sketch, and these really are sketches, as you can see I'm not paying an awful lot of attention to them. We can see on the larger one, the bottom here, and we'll put those on, let's do it in white so you can see it slightly better. The larger one is 7, the smaller one is 4. So what we have here now is already our scale factor, 7 over 4 or 4 over 7. If we think about the larger one now, Q is just here. This angle, remember, is that one is that one, and we'll put the double there and the double there. So with Q, that will correspond with the 2.8. So the 2.8 will be with the Q, that's going to be just there. If we then look at the smaller one, we have P just here, and that will correspond now with the 4.5 just there. So that's what we've got. So no issues at all. A common error is that students match the Q up or the P up with the wrong one here. They go on there and say that the P and the Q must be the same. They're not. It's not. It's not the P and the Q the same and the 2.5 and the 4.8. It's the Q and the 2.8 and the P and the 4.5. So as you can see from here, it's yet again a straightforward problem to solve for both P and Q. P over 4 is simply going to be the same as 4.5 over 7. Q over 2.8 would be the same as 7 over 4, or Q over 7 is 2.8 over 4. I'm even not going to go through these because hopefully now you see the technique to do it. It's really not that challenging. This one just here, again, no issues with this one. If we look at this, we've got two parallel sides here, the 4 and the 2.5. So this angle right here, if we look at that one, let's put that on there. Just using alternate Z angles, it is going to be this one just here. Generally speaking, you can't use in exams in this particular course the term Z angles, so alternate is the more mathematically rich term or mathematically correct term. Those are the same. So if you wanted to draw the two triangles, we'll draw the smaller one, and you don't need to draw these accurately, clearly, they're just sketches such that you can go ahead and match the sides up. Two parallel sides, so on, let's put that on and let's put that on. We've got now, this, remember, is the larger one, so let's do that, let's do that. This is the smaller one, let's do that and let's do that. Clearly that top angle will be the same, opposite angles, they share that angle, or if you like, if you spun it round, it's the same angle. So on the larger one we've got 4, on the smaller one we've got 2.5. So straight away that's your scale factor. What is it, 5/8 as a scale factor, if you want to look at that. Now, let's look at what we've got with this one. With the smaller one, we got Q, we got 1.4. So all we got to do is match this up. With the Q, we will get now the 3.3 on this one. Just turning it around, the Q will go with the 3.3 and the P will go with the 1.4. So P over 4 is 1.4 over the 2.5. Q over 2.5 is 3.3 over 4. Q over 3.3 is 2.5 over 4. It's straightforward. All I want to do with these particular types is just show how you could split it up if you're not confident to spot which goes with which by rotating that. And if you've got some tracing paper, you might even want to draw it and just spin it about that point and match it up. And you'll quickly see that the P lands on the 1.4 and the Q lands on the 3.3. Okay, let's look at this one. So what we'll now do is look at these in context. So we'll be told that these are similar triangles. It says find the area of the circle below correct to one decimal place. So we're really stepping this up a bit. I'd suggest that in the question you're told that these are similar triangles, and we're told now on here. So AED is a straight line, A is a diameter, we got all of these dimensions, this is a tangent. Okay, now with a tangent touches a circle at right angles. So I'm just gathering all this information before we go ahead. So let's put this on. So if we got a tangent touches the circle, so ABC is a tangent, that touches at right angles. We got a diameter, so this here is going to be the radius, this here is going to be the radius. We've got some dimensions, and all I'm going to do is go ahead and put this up. So you will be told that these are similar triangles, so let's go ahead and put these dimensions on. With a question like this, I go through it, I talk through it, but often I'm trying to work it out myself, especially if there's loads of information. So let's just put this on. So what we need to find for the area of a circle, my first thought is that the area of a circle, A, is equal to pi r squared. So let's go ahead and try and find this. So we need a radius. So if we can get this length here. So this one is going to be A, this is going to be B, this is going to be E. This is going to be A, this is going to be C, and this is going to be D. We know that these are right angles. We know now that these are parallel on here, as we would have been told that they are similar. And of course we've got the right angle here and the diameter. and we're told now that AED is a straight line, which of course means that these are similar. There's loads of ways we can back this up. So let's put the information on B to C. So B to C is going to be 4 centimetres. So let's just put that there. B to C is 4 centimetres, that's there. C to D is 15 centimetres, so we'll put that there. We can put it just here. A to B is 8 centimetres, okay, that's fine. So we can put these on here. So A to B, that's going to be 8 centimetres. A to C, therefore, is going to be 12 centimetres. Okay, are we told any other information on here? AED is a diameter, that's perfectly fine. So essentially what we're trying to find now is this side length, A to E. So let's see if we can go ahead and do this. Okay, so what I'm going to do is find this length, E to B. That's my first task. This is quite a nice question, actually. I like this one. So what we can see is the following. Let's just call this length right here. Let's just call this X. So what we can say then is that X over 8 must be the same now as 15 over 12. So X is going to be equal to 8 times by 15 over 12. Alternatively, you could have said, well, actually, if we look at this, this is 2/3 of this one. So this is nice and straightforward from here. 2/3 of 15, X is going to be equal now to 10. So if we look at that, X is going to be equal to 10. So all I've done is found that length there. If you've got a quicker way of doing this, it'd be interesting to see it. But again, it's relatively straightforward. Now, what I'm going to do is find this length right here. I don't have this one, so what I'm going to do is use Pythagoras' Theorem. This is one of our special little triangles. It's 8, 10, therefore this one is going to be 6. A squared plus B squared is equal to C squared. So what we've got here now is A squared, which is this length, plus 8 squared is equal to 10 squared. So we can see that this is going to be 10 squared minus 8 squared, square rooted. So that is going to be 6. So if this side length is 6, let's go ahead and do that. That side length is 6. So the radius here is going to be 3, and the radius here is going to be 3. So the area is simply going to be pi r squared. So it's pi times by 3 squared, which is 3 times 3, which is 9 pi. So that's going to be on here 9 pi centimetres. I enjoy that, I have to say. I have to think about it. 9 pi centimetres, 28.27. So 28.3 correct to 1 dp. So we've used similar triangles here. We've looked at the proportion. We then considered our bit of Pythagoras, then found the radius and scaled up. If you've done that quicker than I did, well done. So there we go. That is looking at similar triangles. We had quite a tricky question at the end. You're just looking at the proportion of two triangles being the same. You match up corresponding sides, look at their ratios, solve an equation if you have to, and then simply plug back in where required to find the missing values.